Hello students, we had earlier seen about the probabilities, the basic introduction to the probabilities and the types of probability distributions. And in that we had seen our first probability distribution, that is binomial distribution. Okay, now this video is about the second kind of probability distribution, that is Poisson distribution. Okay, now Poisson distribution is also a kind of binomial distribution. Okay, it is very similar. See, in binomial distribution it were only two possibilities, that is either success or the failure. Okay, now this, and there were n number of trials, right? Now, in this Poisson distribution, this case is the continuation of that binomial distribution, kind of. And in this case, the only difference we have is the difference in the formula, as well as we have some assumption that this n, the number of trials, n is very large. Okay, that the number of trials is very large, and my small p, that is my probability of success, is very low. That is what kind of rare events. Okay, now we have to introduce one more term, that is np is equals to m. This m is my mean of the successes, or mean of the events happening, or this even sometimes represented as mu. Okay, so that is one and the same. This m and mu are one and the same. It is just a matter of notations. Okay, rest all notations like r, which is the probability or the number of successes, is similar to the one which is we have seen in binomial distribution. Okay, now one more thing is that I would like to note. See, I had explained in the class also that about the variance. I had given an example that when it is for the sample and for the population, the notation changes. For sample, the variance was represented by small s, and for the population, I had told when it is about the variance of the population, it is denoted by sigma. Now, similarly, about the mean, when the mean is of the sample, it is either my x bar or m or anything, but when the mean is of a population, it is mostly represented by mu. Okay, so this is just a matter of notations, nothing much. Okay. Okay, so now in this case we have the formula of my Poisson distribution, that is probability of r successes is given by e raised to minus m raised to r upon r factorial. Okay, and what is this m is my n into p. N is what? The number of trials, and p is the probability of successes. Okay, now this m can be given directly into the question, that is as the mean or the average. Okay, or if number of trials and its probabilities are given, we can calculate this m value. Okay, now e value we know very well. E is equals to 2.7183 is the value, we know this. Okay, or even when you are using the scientific calculators, you can directly calculate this e value, e raised to any power. Okay, the option appears into the calculator. So this formula can be also modified as e raised to minus m is what? N is by n into p into n p raised to r upon r factorial. Okay, so this is the formula which we'll be dealing with. Yes, now this is a characteristics which I had explained just now. The Poisson distribution is a discrete distribution. Yes, why discrete? Why? Because there are only two options, either success or failure. There is nothing in between, similar to the binomial distribution. Okay, such kind of things are called as discrete distribution. Okay, now my binomial distribution was also a discrete kind of distribution. Okay, that is what, if you plot its graph, it won't be continuous. Okay, Now there are two functions, continuous and discrete. Discrete is what? The separate values, that is success and failure. There is nothing continuity in between. Okay, but now if you go to see the third kind of distribution, which has a continuous graph like this, which I had explained as the normal distribution. Okay, now this distribution, the third distribution, is my continuous distribution. Okay, so these first two, the binomial as well as this Poisson, are my discrete ones. Okay, and the second characteristics is that np is equals to m, and this will be constant throughout the experiment or throughout the problem for one experiment. That number of trials will be same, the probability will be same. That means np m will be same. Okay, and this is the formula which we will be using. Let us be clear with this with an example. Okay, now let's see this example. Okay, what does it say is, on an average, five cars arrive at a telephone booth every minute. Okay, assuming this as a Poisson distribution. Now this has been directly mentioned in the Poisson question that this is a Poisson distribution. That means you have to use this formula. Probability of our success is equals to what? E raised to minus m into m raised to r upon r factorial. Okay, this formula is to be used, that is clear with this line, that it is a Poisson distribution. What is the probability that exactly three cars arrive in 1 minute period? Okay, now before proceeding with the problem, I'll just state this. Now see, here it is mentioned that this is a Poisson distribution. Okay, sometimes it may be given that, assume that this is an exponential distribution. Okay, why exponential? Why? Because see, this formula of this Poisson distribution has an e into it, that is exponential powers. Okay, that's why this distribution is also sometimes called as exponential distribution. Okay, so either Poisson distribution or the exponential distribution may appear in the question. That means it is one and the same, and you have to use this formula itself. Okay, now let's proceed with the problem. Now let's see what is my success. Now in this case, what is asked, that the probability of exactly three cars arriving in 1 minute is asked, right? That means my success is the arrival of car. Okay, so let me just note down this. Success is arrival of car. Okay, now either I can find p, or I can find n in number of trials and all, or I can have directly m value. R is known, that probability that exactly three cars arrive, that is three successes, right? Therefore R value is directly known, R is equals to 3. So I can substitute it here. R value is known, this therefore R factorial is known, E value is known to us. Now what remains is finding the value of m. Now m, I had explained, m is equals to np, where n is number of trials and p is the probability. Now it has never been, nowhere mentioned that how many times this has been occurring. Okay, but instead what is mentioned is, on an average, five cars arrive at a telephone booth. On an average, average means same as mean. Okay, that is another value of mean. Okay, average mean. Okay, so what is given? Average, that is m, right? M is what? Five cars arriving per minute. Okay, so what will be the average? Five cars per minute, that will be the rate, average rate of the arrival. Therefore my m value will be 5 in this case. Okay, so I can, now I have my m value, I have my r value, so I can find this. So that is what my problem will be. Probability of that exactly three cars appear, or arrive rather, arrive, will be what? E raised to minus 5 Then 5 raised to r. R is what? 3. Okay. Divided by the 3 factorial. So it will be what? E raised to minus 5 into 5 cube upon 3 factorial comes out to be 6. 3 into, or rather I would write it 3 into 2 into 1. And it is this e raised to minus 5 you can directly get from your calculator. And what does this comes out to be? The final answer is 0.1396. Okay, when you simplify this answer you will get this as the answer. Okay, so this is the probability of 3 cars appearing per minute. Okay, so this is the end of this problem. We'll see one more problem which we can solve. Now this is the problem. See, slightly a different kind of problem. See, in this case, in the first problem, directly the m value was given. That is on the mean value. That is on an average value of the car arrivals. Now let's see this problem. What is the difference in this? The example says, in a town, 10 accidents takes place in a span of 50 days. Okay, assuming that the number of accidents follows the Poisson distribution, find the probability that there will be 3 or more accidents in a day. Okay, in a town, 50 accidents takes place in a span of 50, sorry, 10 accidents takes place in a span of 50 days. Okay, now see, these are the things which you need to note. First thing is that you need to search for this word, that is Poisson distribution. That means what you know, probability of R successes is equals to what? E raised to minus m raised to R upon R factorial is the thing you need to find out. Now you need to search for your R and you need to search for your m in this case. Okay, now the question is about what is the success. You need to find a probability of some accidents. Okay, so success means there is an accident. My accident is a success. Okay, now what is given? In 50 days 10 accidents takes place. Okay, so 10 so what is the rate of the accidents? Rate is what? 10 accidents per 50 days. Okay, so now I need to find the average of that per day. How many accidents will be there? X accidents. So that means what? 10 accidents per 50 days. That means if you cross multiply this, it will be 10 into 1 is equals to 50 into x. That is x is equals to 1 by 5. That is 1 by 5 accidents per day. Yes. Okay, so this you can treat as your m value or your mean value. On an average 1 by 5 accidents occur per day. Okay, so m will be your 1 by 5. Now next is what you need to find out, that there will be 3 or more accidents in a day. Now, 3 or more. That means what? There can be 3 accidents, there can be 4 accidents, there can be 5 accidents, or 6 or 7 or 8 or 9 or 10 or anything. Okay? So in this case, what you have to do, the easier will be probability of 3 or more will be equal to 1 minus probability of less than 3, strictly less than 3. Yes, the probability of this will be like your complementary events, even and even complement. This is like 3 or more, and this will be strictly less than 3. Okay, so if this one will be easier, why? Because less than 3 means how many terms will come? Probability that there will be 0 accidents, this is the probability that there will be 1 accident, and probability that there will be 2 accidents. So only these 3 cases will come. That's why I'm using this formula. But if you can calculate probability of 3 or plus 4 accidents plus 5 accidents plus 6 accidents, till 10 accidents, then that is also fine. Okay, but just this one is easier using this only three things. I'm using this formula. Okay, that the probability of three or more accidents will be three or more accidents is same as 1 minus probability of less than 3 accidents. That is what 1 minus probability of r. Now number of accidents is my number of successes, that is r value. So it will be r is equals to 0 plus probability of r is equals to 1 plus plus probability of r is equals to 2. Yes. Okay, so this will be like 1 minus, I need to solve for this. I have this formula, your m value we have found 1 by 5. So it will be what? E raised to minus 1 by 5. Now in this case, m is what? 1 by 5 raised to r is 0 upon 0 factorial. Okay, plus now my r is 1. So it will be what? E raised to minus 1 by 5 into 1 by 5 raised to 1 upon 1 factorial, plus now my r value is 2. Therefore, e raised to minus 1 by 5, 1 by 5 raised to 2 upon 2 factorial. Okay, now I have substituted everything in my formula. Now the only thing remaining is simplifying this. Okay. Now what I will do is I can take this e raised to minus 1 by 5 outside. That is common to it. So I can take it outside the bracket just for my simplification. Okay. 1 minus e raised to minus 1 by 5. I have taken it outside. Now what remains in the bracket? Now 1 by 5 raised to 0. Now anything raised to 0 is 1. It is well defined to be 1. Okay, 1 divided by 0 factorial. Now 0 factorial is also 1. So this first term only 1 remains. Now from the second term, what remains is 1 by 5 upon 1 factorial. So 1 factorial is 1, therefore 1 by 5. Now from this third one, this one e raised to minus 1 by 5 has been taken outside. What remains? 1 by 5 the whole square. 1 by 5 the whole square is 1 by 25 into this 2 factorial. 2 factorial is 2. Okay, so this is what I have found. Now if you continue this, what you will get is 1 minus, now e raised to minus 1 by 5. This you can get from your calculator, that is e raised to minus 1 by 5 is 0.8187. Okay, and this value you will get to be, if you simplify this, it will be something about 61 by 50. Okay, this is a just simple simplification. Okay, and this one will come out to be 1 minus 0 point some 998, that comes out to be 0.0012. Okay, so this is my probability of that there will be three or more accidents. Okay, so this is how this Poisson distribution problems have been solved. Okay, that there should be the word Poisson distribution into the problem, and you need to just identify what are your successes, what is your R, and what is your M. That is more important. Okay, thank you.